Hi everyone. This is going to be the story of why and how we developed Detox. It's an open source mobile end-to-end testing framework that we're working on at Wix, and how we use it internally in the company. So Wix bet on React Native about 3 years ago when it was very young, when you can find the missing brink on every step that you made. And especially if you took the technology for more than just a spin. So maintaining quality level of apps is much harder when they grow and evolve. And end-to-end testing was, and still is, a big challenge in mobile, and especially with React Native. So hi, I am Rotem. I'm a part of a mobile infrastructure team at Wix. My team does infrastructure work, defining and building development and the integration process of our application. We devote a big chunk of our time for testing infrastructure and methodologies and building better tools for our developers. And most of the things that we do are open source. Okay, so let's dive in. The biggest issue in end-to-end tests is flakiness, and in all platforms, in web, iOS, and Android. The issue for flakiness is that, what is flakiness? Flakiness is, well, tests may fail without no code changes. Tests are non-deterministic. There are many moving parts inside the app, so they may finish executing in different order, in different test runs, and in different environments, in CI or in our computer. They have uncontrolled inputs that may vary, that have uncontrolled outputs, of course. We can't rely and be sure when the application is idle. So users of end-to-end testing frameworks usually have to deal with synchronization manually. So they just use multiple sleeps all over just to make the tests pass. In fact, we embrace that fact that E2E is flaky, and we created patches like sleep and retry, and it's kind of like putting multiple band-aids over a strainer. You can never get out of it. So this is actually something that we did in the previous testing framework that we used over 3 years ago. And what you can see here is that we're just looking for an element, and if it's not found, we sleep for 50 milliseconds and then continue for 20 times. So 20 times. So it's about 1 second, but what happens if the element is only disappeared after 1.5 seconds? So we don't really know how to control this. So how unreliable a flaky test suite is? Let's calculate the probability of a test suite to fail. So let's define the equation. Q is the probability of a failed test, and N is the number of tests. So Y minus Q is the probability of a single test to succeed. Y minus Q at the nth power is the probability of the entire suite to succeed. And 1 minus all that is the probability of at least one test to fail. So if a test is flaky 0.5% of times, and we have 20 tests, we'll have about 10% of failing test suites. And if we have 50 tests, it's about 20%, 22%. And if we have 100 tests, well, you get the point. It's very unreliable. So we've used Appium for 2 years in general and 8 months with React Native. And we found that we've invested a lot of time in just petting the system and instead of actually writing features. We found that end-to-end was really hard. Tests were flaky. We got different results in different environments, which the only solution for was adding those dreaded slips. And of course, those slowed the tests. And so the benefits of testing have to outweigh the cost. And frameworks which are complicated and fragile can occupy a very big chunk of our time. So, well, but it isn't actually Appium's fault. Selenium, Calabash, and other they have the same characteristics. They all do black box testing. So black box testing is a method of testing things from the outside without knowing what's going on internally. That's much better now. So in mobile, black box end-to-end essentially goes over the view hierarchy and looks at the element. And if it's not found, then it sleeps and continues looping until an arbitrary timeout that we choose or the framework chooses for us. And if it's found, then it interacts with the view. And if it's not, it fails. So the same principles apply to web black box end-to-end. So let's try to make a quick poll. What's the proper timeout parameter? Who here thinks it's 1 second? No one. Good. 2 seconds? Great. 10 seconds? You have 10 seconds? Okay. So, well, none of them is correct, obviously. I mean, think how unfair it is for users to provide this timeout parameter. They have no idea what's going on inside the app. They have no idea if the network finished or a disk is done writing or anything, or maybe the app just didn't render yet. So this is the actual main cause of flakiness. So for us, black box was a dead end. And with Detox, we take a different approach. Well, Detox is gray box. It does gray box testing and not black box testing. This allows the test framework to monitor what actually happens inside the app and actually synchronize with it. So gray box essentially uses a piece of code that is planted in the app, and it can see what's going on inside it. So unlike black box, gray box runs in the same process of the app. So actually running in the same process, and has access to its memory. And it can monitor the execution process. So being able to read internal memory gives us the ability to detect what's going on inside this process. If we have network requests in flight, if there are animations that are currently playing, if the main thread is still doing stuff, and it can execute on the main thread or on any thread if we want. So whenever we do an action or an assertion, we know that the main thread is occupied and it will never change while we do this action. So any action is like, it's atomic. The leading native gray box drivers are developed by Google, Earl Grey for iOS and Espresso for Android. And these frameworks can synchronize with the application, making sure that we interact with the app only when it's idle. The underlying synchronization mechanism used in these frameworks called idling resources. So the way it works is, well, instead of retrying an action or an assertion on the UI, they will query internal resources inside the app every few milliseconds, or have a callback that's saying, for every resource that says, okay, I'm now done, I'm ready. And they listen to those callbacks, and whenever they switch to idle mode, only when everything switches to idle mode, the test will continue. And only then it will interact with the UI or assert on the UI. Detox does not rely on WebDriver, since this is not the web. Detox communicates with its own native driver, which extends Earl Grey and Espresso, and using a JSON-based reflection mechanism that we'll talk about in a few minutes, it allows common JavaScript implementation to invoke native methods inside the app, inside the process. This is how a simple Detox test looks. Well, as you can see, no need to synchronize or add sleeps or wait for stuff to finish. Detox is inherently synchronized with the app. It's cross-platform. The test code is unaware of the platform it tests mostly. It is test runner independent. So this example actually does not even show which test runner it is. It could be whatever JavaScript test runner. Yeah. And debugging, it's debuggable because we use async await and those native constructs. So instead of putting everything in a promise queue, we just go by the we can just use breakpoints and they will work as expected. Traditionally, test frameworks evaluate the expectation in the test script running on the computer. So this means that it will query the device, will give all the data back to the computer, and then the computer will do whatever it needs to do with it. But with Detox, we evaluate the expectations on the device itself, directly on the tested app, on the same process, running on the simulator or on a device. This enables operations that were impossible before, and due to different scope or performance reasons. Okay, so going back to the invocation mechanism. This is what those lines are translated to in the JSON invocation mechanism. This protocol allows multiple native functions to be invoked with just typing this in the test runner. And we can feed each function in a return value of another function. And this way we have a complete freedom to invoke whatever we want on the device with JavaScript from Node on our computer. Let's take a high-level diagram. Let's take a look at the high-level diagram of Detox, and with a few examples to see and try to understand how Detox actually works. So on the test runner, we run an action or an expectation and just await on a promise. And then on the tester, the expectation is being serialized into that nested invocation JSON that we saw. And in the server, the server is actually, it's nothing. It just relays messages between those two WebSocket clients, which are the test runner and the device. On the testee, the device, the action expectation is invoked through that method reflection. And only when the app is idle, this invocation is actually executes. So then whenever it executes, the invocation result is being sent back, and then the promise is being resolved. Or rejects, of course. So this is Detox's own end-to-end tests on Android. Go. Okay. So this is the emulator running the test app of Detox. And the console is running the tests on the left. And this is Mocha running the test suite, but you can use whatever test runner that you want. Every line in this console is a new and isolated scenario, so it restarts everything from the beginning like it was fresh. And this is very easily can be sharded, and we know how to do it with Jest today. And also, it's pretty fast. Look, end-to-end test in 293 milliseconds. So during that year and a half that we're working on Detox and using Detox in production, we've been using it to automate and improve the release process. We've used it in multiple testing scenarios, but it's an iterative process, of course. And as we went along with it, and fixed issues in Detox, of course, and came with a few understandings of how and what actually makes sense of testing with Detox. So in general, there are two types of tests that my team uses Detox for, production E2E and mock T2E, or UI automation. The main characteristics of production E2E is that it involves every part of the system. So we don't mock anything, and it's the closest thing to a real user. It has many uncontrollable variables that can affect the test outcome. If the network is down, the test will fail. If there is the servers have issue, the test will fail. And if we get different A/B tests on different runs, of course, the test will fail. So production E2E have their own pros, of course. These tests are very close as possible to real user experience. Logging with real users' credentials against production endpoints, and it's very easy to set up. We just just launch the app, use the Detox API, and that's it. You don't have to do anything else. And it's very easy to write because you just find an element and interact and expect for something to happen. And those tests can provide very high confidence if they just weren't so flaky and slow. The main benefit of them is that they can they can help QA engineers replace manual testing methods. But again, they will never be as rock solid as, and therefore they're very hard to maintain. So mock D2E, on the other hand, tries to eliminate all this setting by just setting a controlled and predictable environment and replacing all endpoints with mock servers and data. The server and client can then be tested using contract tests. So mock D2E, the pros of mock D2E is that they're much closer to the actual code. They're stable because we're using mocked endpoints and we control the inputs and outputs of the app. So we have a predictable environment. And it's very easy to maintain because once you write it, it should just work. But of course, it never is like this. And well, the cons is that they require much more setup. You now have to mock all your production servers and start mock servers in your tests, and it's a lot of hassle. And they're much harder to write since we just need to mock everything. So there are a few mocking mechanisms for mocking on end-to-end tests. Well, Detox has a few useful mechanisms that we're going to talk about now, but I'll focus on React Native specifically. This can be done with Gradle build flavors or with on Android or with configurations on iOS. So in order for the app to just use a mock server, we'll need to make the app know that it should not connect to a production endpoint. And one way of doing it is creating a new flavor of the bundle, of the JS bundle, and just point it to the direction that we want. So this is actually supported in Metro Bundler, and just by creating any file.e2e.js, we can override e2e.js and create a custom JS bundle, which now points everything to the mock endpoints. So with very little modification, React Native can support multiple build flavors. So for those of you who are using React Native pre-55, you can use React Native Repackager. It's a library that we wrote, which actually is just a patch file, and you can just run it as a patch on React Native and get whatever you need to mock exactly as React Native 55 an app. And well, that's the setup process. So let's see how the setup itself looks. So we'll create endpoint.e2e.js along endpoint.js. And as you can see, we have just a different endpoint here. Adding rncliconfig.js to the root dir of your React Native project and just defining get source extensions will provide any given source extension over the default one. So just by triggering each of those three commands here with this environment variable, it will take e2e.js before, it will just prefer e2e.js on JS files. So instead of bundling in those endpoint.js, it will just bundle endpoint e2e.js. This is an actual test from our mock D2E test suite. Mock server is an object that lives inside the test runner process. So it lives alongside with a Detox tester. And it can be altered during the test suite using simple function calls. And with mock data, we can just set mock data on this object and then just run the app. So now we can run mocked tests and that verifies the application can persist login information, and it does not show a login window on subsequent launches after we logged in. Another method worth mentioning is testing the application output by gathering requests that are actually coming back from the device, from the application to the mock server. So in this case, we see simple notification server that records and unsubscribe requests and just and And by triggering the application to send these requests, we can make sure that they're being sent correctly. So launching a freshly installed app and then logging in and checking that the server still didn't get any device token. Then clicking allow in the app, which then should just trigger the app to send a token to the server using the registry request, and validate that the server has got the token of the last registry request. So there are a few more mocking mechanisms built in Detox, and we use them in our mocked and production end-to-end test suites when we have to. This allows the tests to be more predictable than what they would be without mocking, and thus more stable. And this is what we like, stable tests. And so now we have pretty consistent results with our E2E. But I want to emphasize this again. Don't act according to app state, control it. So this is very important, and I wish I didn't have to say that. We do this when we do unit tests, right? We control everything, control all the inputs, and we get the outputs that we want. So why we act differently in end-to-end? So in fact, wait a second. Okay, that's better. We kind of learned it the hard way though. If we have conditional tests, we have to mock the state and separate it to one or more tests. But the one rule I think that guides us is that every test scenario has to be predictable. So if we have predictable inputs, it should manifest predictable outputs. Okay, so Detox help us write better features with more confidence that these features actually work, and that we didn't break the older features. But there are still a long way ahead of us, and we move in two parallel tracks. The first is internally at Wix. While building products, we incorporate both end-to-end methods in our development and release process. Or at least that's where we're aiming. We're aiming to this for, I don't know, maybe more than a year. And we're still not where we want to be. But who is? So we set our goal on continuous deployment, like that's an ultimate goal. And we're working hard to lower our reliance on manual QA. So one of the integration challenges that we have, we call it approximately zero manual QA. And we're trying to practice it now. So what we're trying to do is the developers, they write the unit tests, they write mocked end-to-end tests, and contract tests as a part of the product development. This is, of course, incorporated in CI. And every build, every commit, it runs all those test suites. But it shouldn't take long, between 5 to 20 minutes, maybe 25 minutes. And this will generate a short feedback loop for the developer. QA engineers, they use Detox to automate their regression and progression suites. These tests will never be as rock solid. Hence, they will be decoupled from the development process. But they can eliminate most of the manual work. Okay, they can eliminate most of the manual work, and when a test is broken, they can test it manually and, of course, go and fix that. Scenarios are owned by the QA team, of course. So dev and QA are obligated to synchronize. QA will need to educate the dev team on how to write high-quality scenarios and review mocked end-to-end suites. And by having a good grasp of what's already being tested in the mock E2E, they should lower the amount of production E2E that they are writing, the amount of regression suites, to the bare minimum. Okay, so Detox development is continuing, and we have a few recent features that we released. Those are here, and so the first one is parallelization. So what we have today is the ability to run test suites in parallel on a few devices. So we use jest to separate, we give the jest the test suites, and it just separates it between all those devices. We got to a point that on one simulator, we had, on one simulator, the Detox test suite took 520 seconds. On 2 simulators, it took 429, and 3 simulators, 243. So this means it's 215% faster. So the other feature, recording test artifacts, we have both images of the beginning and the end of the test, logs of everything, and a video that just shows all the test itself. So this feature is super helpful for us, especially when running on CI machines and things fail and we don't really know why. It is a bit limited on virtualized machines, so if you run it on VMware or whatever, like those that running on Travis builds, they may not have hardware support for video recording on iOS. They do on Android though. Okay, so I want to sidetrack here for a bit. And so for those of you who don't know Detox Instruments, you should. It's our performance analysis tool, currently for iOS only. It can be used to gain great insight of what's going on actually inside the application and inside React Native iOS apps. It's in active development for the past year and few months. It consists of 2 parts: a desktop app for data visualization and interaction, and an iOS framework that is compiled inside the app that we want to monitor. And apart from the usual CPU, memory, FPS that we have with Apple instruments, this tool can monitor React Native internal stuff, like bridge activity. It can actually see exactly what's going on the bridge, those exact messages, what's going on the JavaScript thread, and even network traffic. I believe this will make a huge impact in our app development and bug tracking. Actually, we're in the process of integrating it now into our development flavor of the iOS app. So every build that will be coming out of CI will automatically be able to connect to the desktop app, and then we can just play with it and see what's going on inside the app while we play with it. Also, we'll just have live monitoring. So recently, Wix has open sourced a new library. We called it Compot. It's our new component test library for React Native. Compot uses Detox under the hood. And with Compot, we're able to load components directly to the device screen and control its initial state. And it looks like this. So here you can see Detox driving the app, and Compot driving the component and the component state, and the initial component state. And with this, we're actually able to just separate everything. We don't need to write a special test application. We can just load the exact component that we want and just run the end-to-end on that component. Indeed. So we still have future plans for Detox and the other tools. We want to add hook points inside React Native itself, because today it's kind of hard to maintain Detox with versions of React Native, and whenever React Native version comes out, it has a good probability to break the Detox integration. So we're working together with the React Native team. Actually, Detox on iOS is now running on the React Native CI testing RN tester, which is the kitchen sink UI application of React Native. Collaborating between Detox and Detox Instruments will give us the ability to run performance probing as a part of the end-to-end testing suite, and save and compare performance counter statistics between current runs and previous runs, and raise alarms or fail builds upon performance degraded runs. I believe that this could be industry changer, and well, we'll see How we'll do it in the, I believe that it's going to take us about 6 months, but I'm not really sure yet. Okay, so if any of this sounds interesting and you want to help us build those tools, we're hiring, so come talk to us. Anyone with a Wix shirt, we're here. And so I think I'm kind of done. Thank you.